So thank you guys for showing up. We have this panel discussion, which is emerging technologies in automation, manufacturing, and robotics. So we have a panel of industry experts, people who have spent a lot of years working on solving certain domain problems, working with technologies, and essentially architecting solutions. And without much ado, I would like to invite first Paul Perrone from Perrone Robotics to introduce himself, and we'll do the same with the other panelists.
Okay, that's a leftover custom animation from some silly slideshow. But yeah, anyway, my name is Paul Perrone, Perrone Robotics. I'm the founder and CEO of the company. We develop a general purpose robotics and automation software platform built on Java, 100% on Java. It's been around since about 2001, going from research grade into more commercial and more complex applications over the years. So it's almost 12 years old. And so what spawned my interest in this in 2001 is looking at some charts like this. These are the classic hockey stick curve charts that futurists like to put up there, but there seems to be some consistency in at least the vision that robotics, especially mobile robotics, is going to be an explosive market opportunity. And in the meantime, industrial automation and industrial robots, while sort of not as explosive in the long term, has a still significant market opportunity. None of these charts show the opportunity for defense-related robotics, but that's also an area where there's a lot of opportunity. So this sort of spawned the effort way back when of me saying, well, what would be, what's missing? What are some of the gaps in these applications? Because I had come from the railway controls world, and some of the gaps are you have all these different types of sensors and actuators and PLCs and different hardware systems, and to go from an application to talking to these devices, there's a lot of software that needs to be sort of created, ranging from just communicating with the devices to sensing and measuring information, control and actuation methodologies, and coordinating the behaviors. We've had vendors like from the company SICK who make these lasers that they put out there, and their customers are like, great, well, what do I do with this coffee maker? It's this $5,000 laser system. And they come to us and they say, okay, well, we want applications, and you're the folks who can do that. So how do you do that? So what we've done to close this gap over the years, we developed, it's a patent-pending platform called MAX. It's like I said, a general purpose robotics and automation software platform that enables us to talk to sensors, easily integrate sensors, and actuate a variety of actuation mechanisms and implement control algorithms. And on top of that, or part of that microcosm of making this useful, we've developed drivers that plug in the Max that let us talk to specific sensors. And in many cases, we don't even have to write new drivers. We can just create configuration files that tell our application how to parse the data coming in from RS-232 or Ethernet ports, and automatically does that without any specific driver code. And then we have a host of frameworks for more vertical areas. We've developed frameworks for vehicle measurement, like measuring vehicles on a roadway that we can reapply to different turnpike authorities. We developed some physical security frameworks and some unmanned ground vehicle frameworks. So I'll close out with this rather complicated slide, but this is sort of MAX in a nutshell, and what we do. And so basically, you've got your hardware platform, your operating environment. We've got a Java virtual machine. Everything we do runs on top of Java. We've got different profiles that run on standard, different real-time flavors, and of course, micro flavors. But within MAX, we've got these, we call these sensor building, ways to build software building blocks to build sensor-based applications, actuation blocks to help us of course, actuate DC motors, servo motors, stepper motors, and then assemble those into ways to create mobility packages, collections of motors that implement mobility, and different kinds of planning modules, and what we call container services. Because what we can do, everything is completely configurable. Although we typically configure an application in XML files, we have different sort of mediums through which we can, the data that configures our app can come from a database or a remote server, but the idea is that all of our objects are defined in terms of these configuration files. And so a lot of times an application for us just involves taking existing templates, dropping them down, maybe writing a couple of lines of new code or configuring some configuration variables, and we have an application that works. And so that dramatically saves the time it takes to write applications. And it runs in a lightweight, what we call a lightweight runtime container. You have application components that have callbacks and what have you. But you can also, it's also a high-level API so that you can use standard plain old Java object type of invocations onto these reusable libraries. And we vetted this over many years and across a wide variety of applications, unmanned air vehicles, ground vehicles, hobby bots, industrial automation, vehicle measurement, physical security, and a lot of things like that. And so that's what we do in a nutshell, and I think I'll hand it over to you from there.
Thank you, Paul. So next I would like to invite Tim Biernat from Rockwell Automation, and if I can just get his slides up. Tim. Yes, it will come up.
Okay. I won't need a pointer because I don't have any pictures in this presentation. This is pretty dry. But I promise if you come to our talk this afternoon, we'll have not only all kinds of fancy graphics, but a demo that I hope will work. But Rambir said, tell us a little bit about yourself. So I'm an electrical engineer, trained as an electrical engineer. I worked in a couple different fields, avionics and telecom and whatnot. Had my own business, consulted for a while. For about 6 years, I've been working with Rockwell Automation as a software architect. And this is by far the most challenging space that I've ever been involved with. And talk a little bit more about what Rockwell does in a little bit. But some of the things that I work with the advanced technology group there, and I'm involved in trying to take advantage of some newer technologies and bringing them into what is a very staid technology space, industrial automation. And that includes cloud computing. We're taking a look at using some big data techniques, some analytics, to get more out of the data that we collect, and we collect a lot of data in the factory. We've been working with embedded Java and a couple of products that are in development at Rockwell. And I'm also quite interested in real-time and fault-tolerant systems. A little bit about Rockwell. Who here is like near the industrial automation space? Anybody? Couple? Okay, great. So you're probably familiar, you maybe heard of Rockwell. They're pretty big in North America. It's now a public company, about 20,000 employees, around $5 billion in sales. We're based in Milwaukee. We have a big presence in Cleveland also, where our PLC group is focused. We have labs in Shanghai and in Prague to take advantage of some of the research assets over there. We're in a lot of different verticals, our equipment is, and we do also have a pretty large services arm that's growing. That includes automotive, food and beverage, pharma, increasingly mining and oil and gas. The demo this afternoon is from a fracking operation that we're working with right now in the United States. And we make all kinds of stuff, right? We've got this catalog that's this thick, and everything from like push buttons and field bus wiring stuff, harnesses, up through motor drives, components and relays, PLCs, and software to run the whole kit and caboodle. So what we really want to do is come out and wire your whole company with Rockwell stuff that all works nicely with its parts. Just say a little bit about industrial automation for those of you who are not familiar about this. You know, there's really three kinds or three spaces of industrial automation. There's discrete, if you think about GM or Ford with auto assembly. There's batch food making. I like to think in terms of brewing beer. And there's continuous processes like making glass or steel where you simply can't shut down the process or you lose a tremendous amount of money. We have really challenging environments with our stuff. I mean, these PLCs are put out in a factory that gets hosed down with acid washes and stuff. So you don't put a Dell PC out there, right? That's not going to cut it. But it's hot, cold, it's dusty, it's wet, there's shock, there's EM, wireless doesn't work in factories. There's all kinds of challenging things about this environment. Safety concerns are a big deal. We're very active in a lot of the safety standards bodies because we have to make sure machines don't hurt people. And increasingly, security is on our radar screen. You may have heard of Stuxnet, which was industrial control system had been infested with a virus. And we'll be seeing more of these, I'm sure. It's a very competitive environment. You've certainly heard about manufacturing being competitive and global. And I can't think of a more competitive environment today. Downtime is unacceptable in this environment. So, people are trying to keep prices down, but they've got to have the system be reliable. And these systems are incredibly long-lived. I was in Janesville, Wisconsin at a GM factory where they had our PLC 5s that had been there for 20 years, untouched essentially. So when these guys get a line working, they're going to keep it working. It's like, don't mess it up, okay? And that's not uncommon. And that has serious implications for software. Where's your Linux kernel going to be in 20 years? I have no idea, right? So these are things we have to think about. Real quickly, software and industrial automation is becoming increasingly important. Visualization, communication. Historically, this has been, believe it or not, a Microsoft-dominated environment in terms of supervisory and control and the standards there. That's changing. There's a real desire now to get that factory, which has been kind of walled off, connected to the enterprise, and I think Oracle sees the opportunities that are here, and we do too. We have lots of different platforms today, starting at the bottom on ARM and x86 embedded. We've got PCs that our software runs on. We're running in virtual machines. We're running in the cloud. Lots of different operating systems. Java's really compelling for the 3 Ps, in particular productivity, because these systems have been really hard with native code to have a real productive operation. We also love the incredible open source palette that's available and comes automatically with Java. Some of the challenges, obviously, for embedded, kind of a little bigger footprint for SC standard than we might want sometimes, but we still really want access to that full set of APIs. We need fast response. We need deterministic execution. I'll talk this afternoon about some of the challenges we have in some devices we're building now where, the system has to come up within so many seconds, the screen has to switch with so many seconds, and you need fairly deterministic, not real time, but deterministic behavior, and that can sometimes be a challenge. And we have a nice high level of abstraction with Java, but that can cut both ways, right? Sometimes I want to get down to a memory location or an interrupt, and without real-time Java, that can be a bit of a challenge. So that's it.
Thanks, Tim.
Yep.
So next in line are our manufacturing all-stars. I have Bill Sobel and Paul Warndorf. And I'll get their slides up. And Will, why don't you come up and introduce yourself?
Hi, I'm Will Sobel. I don't have too many slides here, but a little about myself. I'm CEO of and co-founder of System Insights, and I actually come out of the financial industry. I spent almost 17 years developing risk management, trading system infrastructures, exchange systems, and all those kind of things. And after taking a little hiatus and teaching some software architecture course over at UC Berkeley, I got pulled into manufacturing when I started working with Paul on a standard called MTConnect. And I've been the author and architect of it. We debuted it in 2008, and Paul will go into a little bit more about that. But after that, I got kind of the manufacturing bug, and I realized that there was a huge opportunity in this industry to be able to provide new technologies and new software where, in a sense, a lot of the technologies had been kind of forgotten. They hadn't done the same transition to like cloud-based technologies. They hadn't, a lot of the business intelligence capabilities that you're seeing coming up in other industries like the web industry, like web marketing, sales, and so forth, were pretty much unknown. They were still sort of on a legacy platforms. So Athlon and I decided to start a company at that time to develop big data analytics, basically move the data analytics into the cloud, use some of the new machine learning and highly scalable technologies to be able to collect manufacturing data off the shop floor and analyze it. A lot of the technology that's out there right now answers the question of what is happening on your shop floor, which is fine if you want to basically be triaging everything immediately. Where we saw the industry going and the needs of the industry were to be able to answer the question, why did something happen and what is important? So we got to this sort of mantra, being able to monitor and then being able to detect changes right before they happen, and then being able to predict changes based on patterns in data, being able to tell you this is about to happen with a high chance of probability. To be able to do that type of analytics, you need to have very large amounts of data, and you need to have very scalable analytics, plus a whole bunch of other technologies that we've been working on. So our company is focused on figuring out how to make companies more effective when they're producing parts. And if you are familiar with manufacturing, the utilization of equipment is actually fairly low when you're talking about discrete part manufacturing, making things like medical devices and aerospace parts. It's probably in the 30s, sometimes 40%. And there's a lot that can be done with that. And by being able to figure out why things are down, why you're not producing parts, basically we can help manufacturers make more effective use of this extremely expensive, extremely complicated equipment that they have on their shop floor. And that's what we do. So we've been working on open source technologies around the MTConnect standard to be able to allow other people to get access and be able to sort of broaden the base of data availability off the shop floor. Maybe people who don't come out of this industry, discrete part especially industry, don't know this, but to get data off of a machine tool, your standard CNC that's cutting metal, is actually a rather complex problem. And the MTConnect standard addresses that by giving you a standard set of structure and data items to describe the information you can get off of it. Without that, basically, doing what we do would be extremely hard to impossible. And that's one reason that the industry hasn't moved that far forward in discrete. So, a lot of focus on standards, open source technologies. We're releasing tools based on the Java platform out to the industry and out to research and universities to be able to try to raise up some of the capabilities of the industry. So that's what we're up to.
Thanks.
Sure.
Next, I'd like to invite Paul. Paul is our contact for MTConnect, and I'd like him to talk.
Thank you. Good morning, everyone. A little bit of my background. I started in manufacturing in 1965, so you can do the math, how long I've been involved in it. Worked for a number of companies. And recently, well, not recently, 16 years ago, I joined AMT. AMT, well, we're a trade association. We're located in McLean, Virginia, right outside of D.C. And our purpose and goal is to help our membership, which is over 600 strong and organizations, become more effective in their sales and understanding of their product lines. We have offices throughout the world to help members in exporting product and understanding what their country needs are. We also have advocacy. Since we're close to the Hill, we do represent our industry and bring to the Hill what they would like to do and see and changes that they would like to have made. We do research, not in the sense that we have any research, is that we help in focusing on types of research and assist other organizations, universities in constructing research to help our industry out. We have events. IMTS, is anyone familiar with the International Manufacturing Technology Show? We just had that last month. And that was an exhibit show of over 1.2 million square feet of products that were being showcased. It was over 100,000 attendees. So it was a rather successful show this year by leaps and bounds, everybody said. Some of the projects that I personally get involved in is one was a smart machine initiative to help bring intelligence to equipment on the floor. And then other one is MTConnect. Started that in 2007. And as Will had mentioned, our first showing of it was in 2008 at IMTS. What is it? It is a royalty-free, open standard that everybody can use. The purpose of it is to try to get past this interoperability about how do things talk to others. The reason we took this on is our members were actually asking for something of this. They were getting tired of every time somebody had a new application, they had to develop a new interface. And to them, that was a really misuse of resources because most of the time they had to do it for free. Therefore, it was a cost to them. And they wanted some way to get past that, so we brought on the development of this standard. Basically, what it is that every device and every machine, they all have their same, different languages. They speak differently. And as Will said, if you wanted to get the data out of this stuff, it was pretty complex and expensive to do that. What we're trying to do is to take those different languages and put them into one common language, be an MTConnect, and have a dictionary of data items so that as an application or anybody wanting to access that data, they know what it is, how to interpret it, and how to deal with it. And we are building we built the standard on XML so that we could give to our membership and anybody the ability to extend beyond the standard so they can differentiate themselves with product with their own namespace and their own data items. What we've done is we've moved the definition and description of what data is. Usually it's at the application side. You always have to build an interface if you want to get something from a piece of equipment. We've moved it to the equipment so that anybody that would like to get the data and is able to get the data, we're using HTTP, so it's on any network you can pick it up. And if you wish later on, if anybody would like to see, we can give you a little demonstration of, we're looking at machines in India, in Indiana, throughout the world. It's very easy because you can put them on the internet if you're allowed to. But that's a little bit what we're doing. And if you have any questions, please bring them up. Thank you.
Thanks, Paul. So the genesis of this panel discussion was essentially the fantastic conversations I often have with these gentlemen and others in the field of manufacturing, automation, robotics, and essentially domains where technology today has tremendous power to change things. When I talk to Tim about his process automation architectures, it fascinates me. Go back 15 years, 10 years, and you see the landscape totally different. I see Paul Perrone from Perrone Robotics. Robotics in itself is such a cool domain to work. It's great to see Java and emerging technologies showing up and building something meaningful. Manufacturing, between Paul and Will, they have written the MTConnect spec. So when we talk to them, it interests me to understand what is emerging technology, why emerging technologies make sense for these guys. And essentially what we will do is, I have a list of about 5 or 6 questions, pretty generic. I'll kind of ask them, and then we'll open it up to the audience. And if you guys have any questions, we'll let the panel address those. And feel free to stop me in case you have a question and a burning need to get some answers. I won't entertain them, but anyway, I'm sorry. Yeah?
Is MTConnect written in Java?
It's right. It's a standard, so it only specifies the HTTP protocol and the XML schema.
Right.
Can be written on anything.
But it says something about royalty-free library. Were those written in Java, or are those implementation of MTConnect?
Right now, we don't have a Java implementation. It's something that we are working right now with Oracle on getting out there.
So I wanted to start off, and we'll go in this order with Tim, Paul, Will, and Paul again. So what are some of the technology trends you guys are seeing in your domain, emerging technologies which are relevant? Tim?
Well, okay, so there's lots of them, but one that's, I think, really a big deal for us is multi-core. You know, we make some pretty good business out of selling PLCs and all the stuff that connects to a PLC. And in the past, those machines were highly constrained in terms of what you could attempt to do, both memory and processing-wise. Today, we're looking at, you know, soon to be launching 4 and 8 core control systems. So now you can say, not only can I do basic control and I/O, but I could throw on one of those cores a model predictive processor, right, where I'm actually trying to predict some outcomes for the process and make corrections. You could put Java on one of those cores and do some event processing localized instead of collecting all this data up at a higher tier. So for us, multi-core presents a really big opportunity in that space.
Yeah, when we first looked at these market projections for what robotics and automation was you know, back in 2001 and the mid 2000s. You know, was projecting something that was a little further out there, and we as a small company, you know, didn't affect us as much because, you know, we had the ability to focus on research and sort of build design for tomorrow and implement for today. In other words, you know, ride this emerging market wave. So everything we've done has been designed to really capture that high revenue opportunity that's on the horizon. So the trends that I see happening are, luckily, some of the predictions are coming true. So back when we were working with the DARPA Grand Challenge and had a DARPA Grand Challenge vehicle, and it was considered a wacky research project. You know, why would you build a robot that would travel the Mojave Desert, self-navigating car? And now we're hearing more and more about driverless and smart car technology. I'm actually the chairman of the SAE Committee for On-Road Autonomous Vehicle Standards. California is starting to legislate and allow autonomous vehicles to drive on the road. So in just 6 years, we've gone from, you know, completely crazy Star Wars level robot project to something that's viably going to be happening on our roads in the near future. So the trend is that this is, you know, intelligent and robotic automation is going to be explosive. And we saw the same thing in transportation. Using lasers was foreign to the traditional transportation companies that were used to treadles in the ground to detect where vehicles were. And we worked with a company and we put lasers overhead. And that, you know, whenever you mention the term laser, they think Austin Powers or some you know, crazy mad scientist type solution. But in fact, these lasers have real value. These industrial lasers are measuring vehicles and doing things that they never thought that they could do. So that period of being gun shy and sort of dabbling with the bleeding edge is now coming back. It's been a long business cycle, but the trend is that these companies are now starting to see that this is the real deal, that you can actually do things with these advanced intelligent technologies that was only once the purview of science fiction.
Well,
sure. So just going back in time when I first got into this, around 2007, when we went to IMTS, Paul brought us out there, and they did a huge presentation. I mean, see the pictures of it. So it was amazing what AMT put on as far as a show for MTConnect. It's a standard. And we presented it to the public. A lot of the reaction we got was, well, why do I care? Why do I really want to get data off of my machine? It's like, well, you know, they seem to be doing fine. we make parts. And there was a lot of fear also about putting your machines on the network because somebody's going to hack them. It was going to cause all kinds of disruptions, and there was security issues, and just a lack of understanding about what could be done and what value could be added to the process. I've seen over the last couple of shows, and this last show especially, when I start to talk to people, it's more now, okay, what can you do for me to make my business more efficient? So the discussion has really changed from the beginning of why should I care to now really looking for business value and how can we extract as much business value. Same thing when we started the company, we were a SaaS-based company. We were saying, we're going to sell a SaaS-based solution into manufacturing, and people looked at us like we're crazy. Of course, people are never going to let their data off of their network. It's never going to happen. But again, there hasn't been that much resistance. We got interesting also, just from some of the companies we were dealing with, just thought of this. We first approached some of the large machine tool builders back in the beginning. We did these tours, Paul and I. And we went to some of these companies and we told them that we would like to just get a read-only standard that's able to get data off of your machine. And a lot of these companies were saying, well, one of them especially said that, well, if you did that, they're going to be able to reverse engineer how my machine works. And this is going to be, this is going to give us, this is going to allow our competitors to compete, basically do what we're doing, because you're going to be able to see our positions and our loads and so forth. And now they're actually, this company is one of our biggest supporters. So we've seen a real turnaround in the acceptance and the concept that we need to be able to understand and monitor and really get a handle on what happens in these manufacturing systems. And now we're getting into things like embedded devices that are able to collect data from different types of sensors and a whole bunch of different sources. So as I see it, I think the acceptance and the understanding now in the marketplace that these technologies are out there, that my business can do better, can be more efficient, because I can now get information. I'm working off of an information base instead of clipboards and written notes. I think that's a huge change that's really going to impact this industry incredibly.
Paul? Yes. Being in this industry for a little while, when we started the project, we knew the first thing that, and the hardest thing that we were going to be faced with is culture. That we had to get past that, and within the past 6 years, that's starting to really come about. As Will had mentioned, in 2008, people would walk by the booth, or I should say would walk past the booth, because there was no interest at the time. And looking at the economy and looking at what's going on now, and people starting to understand that things can happen. This last show, we've had, I think, most people I've ever seen that wanted to monitor their organizations, their shops. We are working with the National Tooling and Machining Association. That's about 1,600 to 2,000 job shops in America. Help implement MTConnect. The problem that we have is that we're getting past the cultural issue. Now we got to get our hands and get a hold of how much is this all going to cost me. These companies don't have large pockets of money. Therefore, we have to get the cost of implementations down. That's been the inhibitor for all of these companies to even try to think about automating the movement of data and the understanding of the data on their shop floor. So that's one of the areas that we need to really start to pay attention to, is get that price point down, and that's what we're working with National Tooling and Machining Association on trying to do that. To show you how excited our members are is we're going to work on a starter kit. That'd be, we're going to hook 3 machines up, and we're going to give you an application just so you could look at this stuff. Almost all of the machine tool builders will do those 3 machines for free. That they want to get the industries, getting manufacturing up and going on the advantages of monitoring. In all the installations, and just about, you correct me if I'm wrong, people have seen an increase in utilization of the equipment of at least 20%, which is money to them. Yes, ma'am.
When will the starter kit be?
Starter kit, we're shooting for the end, I'd say in reality, beginning of next year. And actually, we're working on a little bit of an application, the freebie application. It's not going to tell you anything more than the utilization of your machine for a week, and after that, it blows up the data. Because we can't compete against those that are in the business of providing applications. But what we want to do is get people on board as the advantages if they do implement this and open up the world to them.
Very good. So I want to ask you guys about an individual complex issue or a problem which you guys are facing and you're solving with technologies. But before I do that, I want to give you guys kind of a human face to these problems which we are facing. So I was reading an interesting article where they said in Singapore, what they're doing is they're overlaying weather patterns on GPS coordinates of taxis, and they're figuring out that cab drivers don't want to pick up passengers when it's raining. And by the way, if you have been to Singapore, it's always raining some part of Singapore. And the reason that they found out they don't want to do that is because they have to pay a bond in case they get into an accident. And that was hurting the cab company, which in the first place was enforcing these bonds. So they did this analytics. They had this mashup of different technologies, and they figured out the culprit was that bond. So they took that bond away, and they saw a 40% increase in revenues. So this is a human face of this problem, where we are using big data, big analytics to solve these problems. So coming back to that question, do you guys, or have you guys experienced a similar challenge and a problem which you have solved using these newer technologies, which you probably would not have been able to do 5 years back or 10 years back? So I'd like to pick your brains on that. So why don't we start this time with Paul?
Okay. If I understand correctly, is what can we do today we couldn't do in the past?
Exactly.
Basically.
Something which is new, something which is complex.
Well, there's a lot of new technologies coming out, and like additive processes. Everybody, if you read the article now and seen on YouTube where you can make parts with plastic by adding it up and everything, and some kids have made guns out of this stuff. So things are moving. I think where we're heading is that innovation is going to come at us at a much faster pace than ever before. And that we need, and today, things are happening relative to innovation that couldn't have happened in the past because technologies weren't available. We have a company that in the past had troubles with their in their facilities. They had pop machines. They have hundreds of thousands of employees, I think, and they're monitoring their pop machines to make sure that they don't break, or if they're going to break, they fix them so that they don't get their employees mad at them. So we're all getting into this new understanding that knowledge is becoming a power. And in the past, we couldn't do that because we couldn't really get the data. And we didn't have the devices. It was too expensive, and nobody just wanted to go there. I think the lowering of the access to the data will bring about greater innovation, things that we don't even know that exist today.
Excellent. So why don't you start, Tim?
Okay.
I'm just kind of mixing it up.
I'll just say the singularity is near. There's something that we struggle with, and our customers are talking to us about. We manufacture a series of what we call historians. And in industrial automation factories, these collect time series data from sensors and from the controllers, and then later on they try and make sense of what's happening in their factory with their process or whatever. Problem is there's too much data. And I think there's two ways that we can tackle that. One is we can take advantage of the scale available in the cloud, so we can move this historian. We have historian on a rack embedded, we have it on a PC, we have it on an enterprise server. We're going to put it in the cloud. So we can collect more data and we can provide more analytics there. But that's not good enough because there's still too much data. So we have to go to the other end and look at the bottom and say, hey, when I'm collecting this data at a sensor, look at the costs of things like putting Ethernet on a smart sensor or an embedded processor today. They're dropping rapidly. So we can start looking at the very bottom where we collect the data and try and make some intelligent decisions there and not collect all the data, but just the important data or the important events that we need to be aware of in those sensors. So I think we need to tackle it at both areas, and we are doing that. For instance, I saw a very interesting product that Oracle had, which is an embedded complex event processor. They had it on big iron, but now they're taking it down to run an embedded Java and embedded spaces. You could take advantage of that kind of technology closer to the point where you collect the data to minimize how much data you're collecting. So I think that that two-pronged approach is really going to be big for us and our customers.
Thanks, Tim. Paul?
Yeah, I mean, one of the things that has happened is certainly in terms of the price of sensor technology has come down, which has been great because that needs to happen. For example, we have designed software to talk to, as I had mentioned before, these SICK, that's the name of the company, SICK lasers, and they can be very expensive, $10,000, $15,000 lasers. So we developed a software package that is sort of sensor agnostic, and that we get data in the form of these high-level points, these point objects, collections of points. So when SICK created a lower-cost laser, we adapted to that, and then when we wanted to go, an OEM partner of ours wanted to go into some retail-oriented organizations that were not going to be able to afford a $1,000 or $2,000 sensor in their application, we were actually able to say, okay, well, hey, there's this $150 Kinect-like sensor now, and the same application software that we use for security works with all three of those lasers without any application software changes based on the architecture. So what exactly we want to see happening is to sort of design this software to be hardware agnostic and be able to leverage this, these lower cost sensors, and in some cases, there's going to be more. They might be more expensive, but more robust sensors for industrial applications versus retail applications. So that's been happening, and that's been a tremendous boon. And the same thing goes. The same applies for mapping data. When we were working with the DARPA Grand Challenge, only a few, in 2005, only a few teams could afford the really, really good data. Now, with some of the projects, an AGV project we're working on, we have access to data that's just about as good, and some of it's free, but it's generally affordable. It's getting more and more affordable. So it's just this technology is this convergence is happening. Sensors are going to get cheaper, and we're going to actually have more and more viable robotics and automation applications. And so that's sort of the biggest change I've seen is the cost reduction.
Thank you. Will?
We've actually, I was just listening to Tim, we've actually gone in the other direction. We collect everything. And one of the reasons we've been doing that is because we feel that you never know what you're going to need. So in a lot of our analytics, we're looking at correlations between something that happened out on the shop floor and some event that occurred. Well, how far back do you need to go? What data is important? So you're collecting all this, sensor data, machine tool data, loads, feeds, speeds, process information, and something happens. Now, let's look back in our data set and see what was highly correlated with that event occurring. So how do you do that? Well, one of the things we found is that you really need to collect everything, and you need to store everything. The good news is that with a lot of the cloud technologies, like we're AWS based right now, and we're using all the latest buzzwords and things, Hadoop and all that kind of technology, to be able to store large globs of data up in the cloud. And this has given us the ability to find things like a customer. They had an argument between the operators and the engineering where basically a machine had failed, and it crashed, and they were wondering, the operator said the part program was wrong, or the machine is skipping a part of the part program, and The engineering said that's not possible, that just can't happen. What you're saying doesn't happen. Well, it turned out to be a combination of problems. A problem that an alarm went off on the machine and the operator reset the alarm, but the machine was in a bad state. It did execute the part program correctly and finished up, and then we noticed that there was some loads and patterns. We could actually see the crash right in the data. We could see exactly what the event sequence was that led up to this, and we knew exactly why this had happened. So we could tell them, this is the sequence, this is what happens. Tell your operator not to do this anymore. If they hit the reset button, they have to actually restart all over again and put the machine back into a home position because it doesn't know where it is. The machine kind of got lost. It had 3 stations, and it got lost, and it thought it was in a different station than it was. So when it tried to move again, it said, oh no, and crashed into something. So you get these kind of questions, and having all the data, having all this information, we can actually solve problems. Again, next time we see this kind of a pattern, we can actually say, hey, I think you're in a bad situation. You should really take a look and make sure they go through the right sequence of reset so that they don't smack their machine again. Because these machines are extremely expensive. A single problem, like, let's say you smack a spindle and you get slightly out of alignment, you're talking about maybe a $10,000 repair. So there's a lot of money involved in this. And you're talking about downtimes, you're talking about loss of production. So when you're talking to companies about these kind of things, I mean, it's not just, oh yeah, this is fun to do. This is true business decisions that are being, true business value that you're adding, and dollars and cents.
Excellent. So I have a lot of questions, probably 5 hours worth of questions, but unfortunately in the interest of time, we have just 15 more minutes left. So what I like to do is I like to open it up to the audience. If you guys have any questions for the panel, feel free to speak up now. Anybody? Yes. Can you introduce yourself? And
my question is about MTConnect and how it relates to OPC. OPC currently has a web service, XML feed. Does that conflict with MTConnect? Are they able to work together?
I think, Paul, you want to take that?
Actually, we are working with OPC. We have a memorandum of understanding, and we're building a companion specification on how you link MTConnect and OPC together. So what we provide then to OPC is the dictionary of the data items and what they mean. Okay.
Thank you. Yes, please.
Dennis Davis, let me stand up so maybe everybody can hear. Lyman Gordon, and this is my 3rd company of manufacturing I'm in, so I'm not an expert in any way, and my wife will confirm that. But I've just got into Lyman Gordon, and I feel like I'm still in 1990. Tim, your area, I mean, the only way I can keep my shop floor running in automation is to link it to my ERP, make it where in my shop floor, my routing is passed through on my shop floor, and they don't have to get in their ERP. Then they stay in there. Then I have a comprehensive system. That's where it was in 1990. I feel like I've got to custom build it again, right? All right. I want that passing through routing, control, engineering, finance, manufacturing, planning, and shop floors coming together in that tie together of my ERP and my shop floor. Routing control is the only way I've done it in the past, okay? Big data. I agree, I need big data because what I'm really wanting is to predict. I'm not only wanting to see it come through, I want to see problems come through that I'm going to be able to analyze those different steps and see problems and get my quality data in. I don't want big data forever, okay? I want to capture just about what you're saying, everything I can to get my predictions up in it. What I really want is a video game on my shop floor. Okay, so I have these 14-year-olds I can hire. They can't do an email, but they can do the unbelievable complexity of a shop floor and planning it. But I know we're different. When I'm trying to tie these in, I still feel like I'm doing the different pieces. I don't have any confidence yet in any kind of standards. EDI is the best I've got in my world, and every EDI project is a work in progress, as solid as they've got. In other words, as I'm coming in the industry, I'm missing something as I'm doing this, that it's there, and I'm just not seeing it, or am I still just trying to work pieces together? And in a factory floor of an old industry like mine, forging, and still trying to put the pieces together. I still feel like I've got to go out there and hire in this world, I've got to hire programmers and build this myself to put the pieces together. That's my question. Am I missing something?
That's a very good question.
I'm just going to...
I'll let everybody take a stab.
I want to take a shot at that. When I came to Rockwell, they said, let's do a research project. Let's hook up the SAP supply chain module to a sample factory, a pharma factory aspirin product line. And that was hard. And we had all the resources available to us, right? And you're right, it's not getting better. And frankly, it's not a technology problem at all. My take is, you know, SAP wants to come down into this space. The people who are in this space don't want SAP there. They want to have their own proprietary solutions. And so they're not cooperating, they're not working together. And until that happens one way or another, it's going to continue to be difficult.
Paul?
Well, I don't have much to say about this, actually, aside from the fact that, you know, it sounds like a, you know, like an area where, like an organization like Oracle, for example, could come in and with some embedded, plugins and tools. You know, it's a big problem. You're looking at, you know, sort of a system level solution that needs to be provided by, you know, an organization like an Oracle or something with their tool set. But, you know, tying to all those different pieces, there is a gap sort of maybe in what's in sort of Oracle world and what's required perhaps to make that embedded connectivity. But there are people here like Dave Clack and some of the folks in the embedded side that are helping bridge that gap, I think. But yeah, I mean that's sort of my rough take on my loose understanding of your problem.
Will?
Yes, I know exactly what you're talking about. Every project, I mean, I think before MTConnect, every project is a one-off. And everybody's building the same damn software. And we've seen this over and over again. Even with getting data off of controllers, I don't know how many implementations I've run across where people have come up with different ways of being able to integrate with controllers, and it's not easy. And, you know, actually PLCs in process are probably easier than CNCs. I'm not sure how much you're forging, so you're probably doing mainly PLC, not so much CNC work, correct? Yeah. So I think that standards can help, because if we can get people to adopt standards, especially if the standards are, one thing that you don't want to get into is a pay-to-play type of scenario where to be able to use a standard, it's going to cost you money, because then you have barriers to adoption. It's one of the things that MTConnect was very cognizant of when we started this project, was to make it open and royalty-free so that anybody could implement it. And I think when you start getting into, you know, again, it's a market maturity situation. So if people can contribute back, sort of like what you have with device drivers and other things along that line, other industries, if you can get people to contribute these solutions back, then yeah, you may do your one-off for your particular scenario, but if somebody else can contribute, if you can contribute that back to the community, then you can start to get this sort of community effect where if you need something, then you can download that from the community and basically use it within your shop. You don't have to redevelop it from scratch. If it all adheres to the same standard protocols and standard vocabulary, then basically everybody can use the same set of technology. So there isn't that ecosystem in manufacturing right now. And that's one of the things that we're really working, you know, from the Institute side to try to build. And there's a lot of resistance in this industry because it's always been, you know, I can come up with my little proprietary solution and charge you, you know, tons of money to be able to use it. And the solutions that they're providing you are basically, they're giving you plumbing. And the problem is that if all you're selling is plumbing and not business value, then I think the focus is really on the wrong thing. We really need to focus on getting the applications and the analytics out there, and not so much focused on how to get plumbing going. Like, if everybody charged, let's say, $10,000 to be able to implement, SNMP on every router or machine, computer that's out there, so you can just find out whether the thing is operating or not. People would say that's ridiculous. Or, put an Ethernet port, $2,000 to put an Ethernet port on a device. Again, this is something we take for granted in other industries, where in manufacturing we really need to get to that next step where these types of technologies are freely available if they're not just already embedded on there already.
So we'll quickly go to Paul, and then we'll do one last question and final remarks. Let Paul answer that, then we'll get to you, sir.
Right. Like I said, this is a big culture change that we're going through to get everybody on board, and it's going to take major influence to be able to have it really come about. We won't solve it today. It's going to take many years to get it done because manufacturing is big. There's so many areas to address, so many things to get in, but we got to get started. AMT, we've got over $4 million of our own money into this standard because we believe that we got to start somewhere and we got to get this thing moving, and we're hoping other corporations and companies come on board to help us out. We have over 105 organizations now helping us with this standard. And it's going to take time, but it's going to take big forces to help get us to where we really want to be and to solve your problems, so you don't have to always hire a slew of programmers to come in, and then you're living with this for the rest of your life. Because any change you want to make is going to be difficult, and when that programmer leaves, you're done.
Thanks.
We're trying to address that.
You had a question, sir.
My name is dealing with process automation instruments. I have heard in that presentation for me two important issues. One is the long-term availability of software, and the second is also deterministic capabilities. What is your vision and strategy using Java to solve these two issues? As Java will be most probably long-term available, but the underlying necessary OS is one open issue, and Java itself, even MD, is not real-time currently. So what is your vision and strategy?
So why don't you start, Tim?
Yeah, so those are really good points. Let me try and answer the first one. The first question you asked was, I think one of the things we're doing is our embedded Linux. We actually went and brought some expertise in. We're working with a distribution called Monte Vista, who they're very active in releasing stuff to the kernel in terms of embedded Linux extensions and where that's headed. And we count on that partner to help us make sure we're going to have a good kernel 10 and 15 and 20 years from now. Secondly, today where we are anyway with Java in the real-time space is rather limited. We need deterministic response times, but we don't need real-time, hard real-time yet. When we get onto one of those cores in our PLCs in our control environment, now we're going to need quite likely real-time response, and that's when I'm going to come over to these guys and see if we can resurrect some of the technology they have from Java real-time and help us with that, because they have some great expertise in that area.
Thanks, Tim. Paul?
Yeah, I mean, we encounter this problem, and so we've worked with Java RTS in the past. We've you know, but there is undoubtedly a lack of real-time you know, JVM solutions out there. But there are some vendors who have Java real-time platforms in this space. There's a handful, but they're out there, and they have different levels of support. And then in the same token, the other level is sort of at the microcontroller level. There are even fewer and farther between options for running Java in like what's considered a microcontroller level environment. But they're out there, and we've worked with every one of them to try to see if it's usable. Some have come and gone over the years, but our strategy is to continue to work with you know, Oracle and whomever can provide these platforms for these specific environments. Like we have a need for QNX and VxWorks and you know, it's multi-core solutions on those platforms. So we work with a handful of folks who have the expertise in that area to provide that, and have had, you know, we have a lot of really good experience with the RTS product, and that's actually deployed and running on the Pennsylvania Turnpike, a real-time deterministic system. We also did it for an unmanned air vehicle, RTS and that, and then some other robotic projects. So, but it is a concern, and that, you know, how long will, you know, is it going to evolve? And we're just going to continue to work with Oracle and folks to see that it happen, and do whatever we can do to support that, because we need it.
Cool. Whit?
Yeah, sure. So I haven't dealt with much of the RTOS level of device integration, and for, you know, a lot of what we do is monitoring from our application side. But we're actually getting into some of the device integration, device inter-process communication areas right now. But from sort of the MTConnect standpoint, we are up at a higher level. We're more at the level of passing information back and forth between devices, like integration between...
We are out of time, so we'll wrap it up quickly.
Okay. I'll stop talking.
It's easy. I know nothing about software, so I can't answer your question.
Anyway.
So with that, we come to the end. Thanks, guys. I appreciate you being here. And we have contact information for all our panelists. We can share that with you. If you have any questions, please send them emails, call them. And with that, thanks a lot.
Good meeting you again.